Okay, so this video is actually the answer to the question of my viewer. So he was asking how to connect PostgreSQL with the aiogram library, how to make it work together. Because in my previous episodes, I already considered a simple architecture using the SQLite database and aiogram 3 library. So it's a very sensible question, how to connect PostgreSQL, how to make this work with the aiogram library. In this video, we're going to build a very simple Telegram bot, which essentially tracks your expenses. And all the expenses are being persisted and recorded in a PostgreSQL database. So this bot implements 3 simple commands. The first one is add, second one is total, and the last one is the list command. The list command will list all the tracked expenses so far. The total will send you the amount that you have just spent based on your history of records of expenses. And add is essentially adding a new expense. In order to save a new expense, you have to type in a command /add, the amount of the expense, the category of the expense, and let's just a node to the specific expense record. We're gonna keep it very simple, just having one simple table which reflects the expenses records. In our next video, we're going to refactor this code to make it more robust and more aligned with modern best practices of coding. Alright, so let's get straight into the implementation. I'm going to create config.py. Config.py will contain all the configuration logic. Here we are going to define database config data class. Database config data class will contain the schema for database configuration. And to make the things simpler, we're going to define a property. This property will return a full string which defines the database based on a given password, host, port, and database name. Then we're going to define settings data class, which kind of encapsulates the database config itself and some other vital configuration values. I'm also going to define a load settings function. This function will be responsible for loading all the environment variables and creating a database configuration instance. And we're going to pass this instance into settings class, and then we're going to return this instance of settings class in our main.py. And then we're going to use this instance to refer to the specific settings and to the specific environmental variables that we have defined in our project. Now moving forward to the database.py or db.py, this file essentially contains all the logic necessary to set up our database. It contains the function createPool. CreatePool just returns the asynchronous pool. We're using asyncpg, which is the module to work with asynchronous PostgreSQL, which is the asynchronous PostgreSQL interface. It lets you to communicate asynchronously with your database, create connection pool, reuse existing connections in an asynchronous manner. I'm also going to define the ensure schema function, which will essentially acquire a new connection from our existing pool, and then it will just execute create expenses table query. This query just contains the creation logic for expenses table, and this is our main entity that we operate on. The expenses table will contain all the information regarding the expenses records. Repository.py will contain the expense repository. This is the interface to communicate with our database entities. In this case, we only have one single entity, which is expense, and then we're going to implement 3 main methods here. The first to add new expense, the second one to list all existing expenses, the third one to calculate the total spent value based on our existing expenses. I'm not going to implement any other methods here because the main purpose of this video is just to demonstrate how you can potentially set up the logic with PostgreSQL. And then we're going to focus on main.py. Main.py will contain the entry point to our application. It has logging basic config setup, which is necessary to log all the events that are happening in our bot while our bot is working. Then we're going to create a bot instance, which has a reference to our settings instance that we have just obtained from our load settings function that we have implemented in our config.py. And then we're just going to include the router object. If you're not familiar with what the router object is, you may want to get back to my previous episodes. And then I'm going to create a repo and just start the polling process. And once we terminate the process of our bot, I'm going to close the pool of connections and just close the session of our bot. And now the last file in our bot. This is the handlers.py. First, I'm going to import all necessary dependencies here. Then I'm going to create a router object. I'm going to define a format expense row function, which is necessary to format our expense row, obviously string. We're going to make use of it. Then I'm going to define a handle start function, which handles the start command. I'm also going to wire up handle add handler, which handles the add command. We need to parse the incoming message. Once the message is parsed, we just need to verify the amount is the actual decimal. And then we're going to use our repo. And our repo is actually passed as the context for our bot. We pass this value in our start polling command. We passed the repo variable as the additional context, so we can reference to this object in our handlers. And I'm also going to define a new command, handle list. This handler will essentially handle the command list and return all the expenses from our database. If our table doesn't have any records yet, then we're just going to respond with no expenses yet. And then we're just apply our formatting and return the final result. And the last function is total. Handle total is the handler to handle the total command, which just calculates the total sum of our expenses, and then it just sends the total logged result. Now, to make sure that everything is working, we have to create the Docker file. The Docker file will contain the build of the image for our bot. I'm just going to use the base image Python 3.9. I'm going to define the working directory, just installing the necessary dependencies in our container, and then I'm just copying the requirements.txt, and then I'm just installing them. You can use UV for those purposes. It doesn't matter which package manager you're actually using. I'm just sticking with the traditional choice of using pip, and then the command python app.main.py, which runs our bot. And the last thing that we have to define here is our Docker Compose. The Docker Compose will orchestrate our containers, so it will essentially contain two main services. The first service is bot. The bot will essentially reference to the Dockerfile that we have just defined. We need to specify the .env, which will contain the environment variables that we're going to export to the process of our bot. And then we need to specify exactly that it depends on the database, if our database is in healthy condition. So first of all, it will try to run database Postgres 15. You can use a different version of PostgreSQL here. And then it just passing the environment variables here. And remember that those environment variables should be defined in your .env. Defining the volumes where the PostgreSQL data is persisted, and then just a little health check with a specific interval of 5 seconds. And then we just need to define the volumes database data. And that's pretty much it. Now let's try to run this bot. Alright, let's go ahead and run this bot. So first of all, you have to make sure that you have installed Docker on your machine. And then we need to open Docker. And once you open Docker, you can type the following command in our terminal. You have to use docker compose up -- build. And this command will basically build all the images and then start these containers. So as you can see, it already built all the images here, and now it's just running them. So let's proceed to our Telegram and see how this bot works. Okay, so I just opened the Telegram and now let's hit start command. So as you can see, there is a very simple description here. You can add new expenses, you can list recent entries, and you can show the total logged amount. Now let me just try to run total command, and as you can see, I have total logged $121. The reason it is not 0 is just because I have already tested this bot before locally, and it saved and persisted all the data in my local volume. If you need to remove this data, you have to remove your local volumes from your local computer. But this is a subject for another video. Now let's try adding new expense. Let's say we're going to add a new expense, let's say $15. This is groceries. We just need to type the node for this specific expense. Let's say this is just node. Our bot actually parses this message and splits it into 3 parts. The first part is the amount of money. The second part, the category. And the third part is the rest of the message. And the rest of the message here is essentially this is just node. And this is just node goes to the node field of our table. If you try now to list all expenses here, you can see there are some expenses created here. And 2 of them were created yesterday. And now let's try to see the total. The total has been increased by $15 that we have just recorded. Now it is $136. So this is the essential functionality of our bot. So it basically takes your expenses and logs them in a database. That's how you can implement very simple functionality using PostgreSQL and aiogram 3 library. I really hope this video was helpful to you and addressed your question. In our next video, we're going to discuss how to build on top of what we already have and make it more robust, sticking to the clean best practices of the architectural design of our application. Alright, that's it for this video. If you found this video helpful, feel free to subscribe to this channel and hit the like button, and see you in the next one. Bye!